Hello everybody, I'm going to give you a short presentation and some examples on FTG salt modeling with seismic. The main discussion points to take away today are that we're talking about one, building salt models faster using airborne FTG, gravimetry and magnetics, and two, we're going to show you the difference between unconstrained and constrained inversion for these salt models. Geospace is an exclusively airborne geophysics company. We have 3 Basler BT-67 aircraft, like the one you see pictured here, and we acquired full tensor gravity gradiometry, gravimetry, magnetics, and LiDAR. A high-level description of the workflow is that Geospace acquire the airborne survey in their aircraft, and our preferred method is to hand it over to Earthfield Technology, who will then perform a depth debasement on the magnetics and include any existing legacy potential fields data, and that depth debasement model is handed across to our other friends at Flatirons Geophysics, who are then able to use that depth debasement as a seed for a full tensor inversion. Full tensor gradiometry has a significant advantage over other methods when it comes to inversions. The FTG maps target geology, and the tensor components that are directly measured relate to strike. It's important when performing an inversion that these tensors are measured and not calculated, because the results are quite different in a 3D datum. Another distinct advantage of the FTG system is that it does not have blind spots. In the image in white, you can see that the signal does not really degrade according to the position under or around the instrument. It's almost isotropic. That's a distinct advantage when you're acquiring in areas of terrain. In the image on the right, you can see a comparison between a partial tensor and a full tensor inversion. Because the tensor components are directly measured with FTG, full tensor inversion allows us to build a 3D model of the base and the topsoil. There are various types of inversion where the base or the topsoil can take precedence, and both may be employed to make sure that the final reconstructed model shows the same dimensions. Here's an example of a 3D unconstrained FTG inversion model from Geospace's library data in the Gulf of Mexico. After comparing the initial unconstrained 3D salt model with their own data, the client may want to include some constraint of their own. The software can handle being given top, base of salt and basement, and those areas will become fixed, while the inversion will allow the FTG tensor components to operate on the rest of the model and allow the salt model to form that way. So if you're having issues picking the salt in your seismic data, come and have a chat to us. We've done this in various places around the world, and we have some nice examples to show you. Using airborne potential fields data, in particular full tensor gravity gradiometry, is a great way of doing an initial unconstrained inversion and building a salt model that's fairly accurate from the off. You can then easily add your own constraint and have a much more accurate picture of what's going on with the salt model. So, in conclusion, airborne FTG is a great way to build salt models. I'd like to thank our partners Earthfield Technology and Flatirons Geophysics for giving me some of the examples and images for this presentation.